Okay, so I promised you guys an update on the brand new cylinder head that we are designing, so here we go. All right, so brand new cylinder head. So as we were just, building up this motor for this Mustang, it aiming to be the ultimate Ford straight six, we knew we were never going to get there with the heads that are out there. We were just never going to win. And so we started thinking to ourselves, okay, what do we need to get there? If we can have any style cylinder head for this motor that would give us max power, what would that look like? And we started kicking the can around. A few things immediately came to mind. One, crossflow. Two, 4 valves per cylinder. 3, very amenable to boost. So taking kind of those primary things in mind, that led us to some technical decisions as well. So for example, 4 valves per cylinder and crossflow. Well, you can't do that with the existing roller rocker, valve train system with the push rods, unless it gets very complicated and very quickly gets out of hand and makes it unreliable and frankly unadjustable for that matter, and hard to service. And it was not something that I wanted to try and engineer. No way. No thank you. So that meant that we had to do away with that old system, and that led us to the decision to go to a dual overhead cam. So we're already at the decision for dual overhead cam for 4 valves per cylinder, which is already in the direction of goodness for boost in most scenarios. And then we started thinking about crossflow, again with the 4 valves per cylinder. You can't really do that with the pushrod system in place. That means it had to go away, and well, what do you replace that with? An overhead cam, or better yet, 4 valves per cylinder, dual overhead cam. Tends to be a little bit more adjustable, works a little bit better rather than a single cam running both sides. So when we thought about that, we need a dual overhead cam, 4 valves per cylinder head. What matches that description? Because we didn't want to start from scratch. We could, but a lot of people have already done great designs and great engineering out there over the years, and so we decided to take some inspiration for that. And so we started looking at the motors that are out there existing today that are in line with this build and have, legendary performance. 3 motors came to mind: the RB26, the 2JZ, and the Barra. Now the RB26 is actually quite a bit smaller, even at its largest configuration. It's I think it taps out at like 170, 180-ish cubic inches. And it was different enough that it didn't quite, make the cut, and didn't know where to get one. None of these motors are going to be easy to find, mind you. They were all meant for sports performance vehicles, and they are all international motors, not U.S. domestic motors. So we knew that finding any one of these 3 was going to be hard right out of the gate. Then we switch over to the Barra. Now the Barra is actually the closest in displacement. It's actually the biggest of the 3. It goes to, I think, 230 some cubic inches, maybe as far as 280 something. I can't quite remember off the top of my head, but the bore size is also the closest as well. So naturally you might start to think that that is the ideal candidate. And then lastly, there's the 2JZ, which out of the 3 of them has the highest horsepower record. I think they built one that's like roughly 2,600 horsepower. Meanwhile, the other 2 top out at about 2,200 horsepower, which is interesting because it doesn't have the biggest displacement of the 3, but I think that actually is part of the reason why it was able to get such high horsepower, because it was able to get that rotating assembly at much higher RPMs, just due to the reduction in mass, but I think that's just part of the reason. Anyway, so that left us down to the 2JZ or the Barra. Didn't know where to get either, and I knew that there are at least some 2JZs here in the US. Didn't know, with respect to Barras, where I would even begin to get one, and as it turns out, found out like a month ago that there's a huge truckload of them just sitting around in the northwest of the United States, so that was interesting to find out about. But starting to compare the two, the 2JZ actually seemed to align more with the old school 68 block than the Barra did, even though the Barra is a descendant of the Ford 200 and it's closer in its bore size. So we decided to go down the route of the 2JZ, and we actually managed to find one, and in really great condition. It was the 2JZ GTE with the VVTi, so that's the turbo version of the 2JZ with the variable valve timing. And huge thanks to Mad Russian Motors, to Oleg here in Denver for providing us with that head. So it was a head that had received some damage from use, but he was willing to part with it. Thank you again so much, Oleg, for letting us use that for the basis of this build. So yeah, if you're ever in the market to go check out some really cool engine builds, or have one of your say JDM type motors serviced or built up, go check out Oleg at Mad Russian. He does a really good job. I got to see some of the motor builds and cars that he was working on while I was there. So we got our hands on the head. Well, where do we go from that? Well, then we move on to scanning the head. And this is where we reached out to a local company here called In the Image. So they did a phenomenal job on this scan. I mean, it is so accurate. It looks so good. I'm sure I'm going to be editing in some images around here. The folks over there that did the model of this post-scan did a fantastic job with cleanup and making it watertight. I'm an engineer. I work with CAD day in and day out, and I can tell you from personal experience that they've got a knack for it, even though they haven't been working at it this long, I don't think. So great job there. Huge thanks to those guys. And actually, we're going to be doing a video on that here in 2 weeks-ish, going through the process of the scan and how it can help, reverse engineering or regular engineering of parts and components, or if you need to replicate something. And so 3D scanning technology is awesome, and we're using it to the full extent here. So we had the head scanned. We're getting ready to get the head back, and then we're going to commit a sin and cut open a 2JZ in order to determine her secrets. But it has to be done for the greater good of the Ford 200. So I hope I don't get too much hate mail on that. Anyway, where was I? Oh yes, head scanned. Gonna start making modifications, but in order to do that, we also need to know how to modify it to the block and what block mods that we need to make. So big shout out to a friend of the show, Nick Schounts. He was willing to lend us his spare block for a couple of months while we took measurements, investigated, and formulated ideas and modeled up the block. So we modeled up the block, did some image extrapolation to get a surface rendering of the block, and then I just roughed in the oiling passages after confirming their rough approximate diameters and then their locations. Big thank you to my friend Andy for letting me borrow his endoscope in order to scope out those passages and make sure that my assumptions about the oiling passages were correct. So now we have the block, now we have the head, we made the two together. Obviously they just don't go straight together. You're gonna have to mod both. On the block side, you're going to have to make sure that the available oil and coolant that's getting up into the head are able to, one, you have enough oil to supplement the two cams and the entire valve train there, since it's no longer a rocker system. And then the coolant passages, you're going to make sure that you keep this head adequately cooled. Scaling it is not going to be too bad, so we'll bring it in, and then we'll take some of the geometry for the combustion chamber, and we'll make sure that the bore spacing is correct, and then we'll do some scaling as well to make sure that it matches the bore diameter of the block. So overall, I think the number of mods that we're going to be seeing here on this 2JZ aren't going to be too crazy. I'm going to try and keep the VVTi portion in there for anybody that wants to play with that. I don't really plan on doing that myself personally, but for the next person who wants to take this motor and run with it, with this particular cylinder head, whenever it becomes available, go for it. I'm going to leave it in there. And, because if you don't want to mess with that, you can always just block it off. Simple as that. So let's see here. Yeah, so we got to make mods to the head, start matching it up, pulling together a hardware list. Where do I go from there? Oh, a lot of you guys have been asking about what the intake, exhaust, everything like that is going to look like. So give you a few details on that end. One, we are going to try and keep the original exhaust exit ports in terms of location and relative size for the aftermarket headers that are available. Obviously not the stock cast iron ones, because those are garbage, and not the stock cast iron head, because again, that is also garbage. Instead, we want people to be able to use stock aftermarket headers that they either already have or can easily get at a relatively low price that are also stainless, and just bolt them right on. That being said, with respect to turbo, which this thing, or boost, this thing is being designed around, we're going to be reaching out to a couple of people that we think would do a really good job at prototyping a turbo manifold for this build once we get to that stage. So we will have that design in mind, and we'll try and figure out a production option on that front. Now, intake, a lot of you guys have been like, oh, make sure it's crossflow, make sure it's not an integrated manifold. Don't worry. First of all, integrated manifold, if you guys have ever watched the channel, you know that that is a non-starter. Never even crossed our mind. Crossflow, it has to be crossflow. Full stop. Especially if you're going to go with 4 valves per cylinder. So you're going to get that for sure. Now, some folks have said, oh, keep the 2V intake manifold, or, something to that effect. Not going to happen. So for starters, this is probably going to look closer to the intake manifold for the 2JZ than anything on the 4200 side, because their bolt-on intake manifolds are extremely amenable to boost. They're dual vane because you have the 4 valves per cylinder, which means you have 2 valves per cylinder for the intake. And for those of us who want to go really, really crazy with the horsepower, that means you're going to need dual injectors as well, most likely, which that particular design is really, really great for. Now, that does not stop you from making like an adapter piece or trying to work with a different intake manifold. But in my mind, I would rather just have a turbo style intake manifold with a single shutter valve for a boost configuration. Can you run NA on that? Absolutely. As long as it's pulling the air into the cylinders correctly without, short supplying the ones in the back, probably works fine. We'll know more once we get some actual test data. And who knows, maybe I'll design an NA intake manifold. I personally have always thought that these engines would look really, really good with a turbocharger on them, either mounted top ways or even upside down if you want to hide it. So I'll take a look into that. What else? Oh, parts, components. So I'm going to be trying and using as much off-the-shelf 2JZ components that there already are. So there's a huge aftermarket for the 2JZ cylinder head components, and some of them have been beefed up to extraordinary levels for extreme high horsepower builds. So that is going to be the basis of this, because I want a robust motor that's not going to break and can dish out the power if you really want to. And even if you don't want to go to extreme measures and you just want a really good performing motor that gets in the 200 to 300 horsepower range, and you want it to be reliable and last forever, the components are engineered to do so. They're not going to be some crappy $2 Chinese made piece of crap. So rest assured there. So we're going to do this right. Honestly, I think the hardest part about this whole thing is going to be designing a new cylinder head valve cover. Because this thing is going to be scaled for the 4200, it doesn't mean that it means I can't use an existing valve cover, and I'm going to have to figure out the stamped sheet metal on that part. Now, initially, I'm thinking a coil on plug ignition type setup. That straight 6 style head with the valve cover, especially since the spark plugs would be now mounted dead center in the cylinders, makes it really amenable to that. But if you want to go to a coil near plug or keep the distributor style, I don't see a reason why you couldn't do that. Especially if you want to go with, say, a Hyperspark and then go with a Sniper EFI unit. Nothing preventing you from doing that. So that's kind of what I have in mind. Now, obviously, the timing will be done via a nodule on one of the camshafts, just like the 2JZ. Plan on keeping that in there, so it should just be a direct bolt-on cam sync unit there. No need to convert the Hyperspark for that. And because it's a cam sync and it's 1-to-1, I honestly don't know that there's a need for a crank trigger. I gotta learn to turn that on. 1 second. That's better. So yeah, crank trigger, don't know that it's going to be needed. Some of you folks have been asking, how do we plan on driving this entire assembly? Well, if you get rid of the camshaft on the inside, which going to a dual overhead cam you're going to want to, that means you can now get rid of the timing chain as well as the timing chain cover. And so we plan to actually go to a belt drive system with an aftermarket dampener. I'm thinking probably a super damper. They make a really good product, and I like what they've seen so far, and they have a wide array. So I'll probably be reaching out to those guys in the future. What else am I forgetting? So, yeah, getting rid of the camshaft. That being said, we're still probably going to have a dummy cam, so to speak, just to provide that additional rigidity inside there. We definitely have to have the cam bearings, but installed askew so they block the oil passages, because since we're not going to be having a cam spinning in there, but we do have the dummy cam, we want to make sure that that oiling passage is blocked off so the oil pressure rises and we get more oil going up to the cylinder head where it's going to be needed for those cams. Now, one of the things I haven't quite figured out yet, and this is the one I've been thinking about the most lately, is the fact that the lifter holes in the block intersect with the primary oiling passages coming off of the oil pump. And that is in order for those lifters to fill with oil, since they are a hydraulic lifter. That means I'm going to need to either put some kind of plug in there or figure something out there. If I can't get enough oil going through the hole in the back, if I can't enlarge that and get enough oil flow, I may have to do something really funky with getting the oil up through those passages. I don't want to do that. That's a more complicated solution that I'd rather pursue. Big fan of KISS, keep it simple, stupid. So that's going to be the approach there. What else am I forgetting? Oh, question for you guys out in the community. This one has been stumping me. So when I was determining the oiling passages in the block, the crankshaft gets its oil from the primary oiling passage. So the oil pump picks up, via the pickup, picks it up, sends it through the filter, and then goes down the primary oiling passage in the block. The crankshaft from the main bearings has holes drilled through to that main oiling passage in order for the oil to get to those main bearings. Now, right next to those are another set of holes that then go to the camshaft and its bearings. So the oil goes oil pump, oil filter, main oil passage, main bearings, cam bearings. We're going to get rid of the cam bearing passage side of things. But one of the things that I noticed is that on the last cam or crankshaft bearing, main number 7, that the oiling hole from the cylinder head extends farther down and connects with that cam bearing there. So it actually has 2 holes there. And I don't know if that's to act as like an oil boost pressure coming off of the rotation of the crankshaft to drive additional pressure there. I'm not sure, but it forms this kind of love triangle of oil that makes no sense to me. So if any of you guys know why that was done, feel free to let me know and inform me, because it seems unnecessary and it's not going to pose a problem for us, but I would like to understand it at the very least. I think that covers it. Now, obviously, this would be made of aluminum for higher horsepower builds. Even though it's weightier, maybe a cast iron might be more appropriate. And you're also going to match the material of the block, which means that your CTE or your material growth with temperature properties are going to remain relatively the same, which is good for stress and everything else like that. I'm getting into the nerdy realm now. So that's where everything is headed right now. Now, I do want to say that this is not going to be ready tomorrow or next week or next month. We have a long ways to go on this, but it is in the works, and we are going as fast as we can on this. In reality, I think this is something that's probably between 12 and 18 months out until it's totally finished, and we have one built and tested. So I'm going to be working on this in the evenings. I still have to make regular progress on the car. I'm going to be spending this 4th of July weekend working on the Mustang, doing the floor pans, the rear suspension, and the rear end, and filming all of that. So definitely got my hands full. We're getting ready to go dyno the motor. There's only like 1 or 2 more engines ahead of us in line on the dyno, and I'm dying to get on there and pull numbers. I know you guys have been asking, and I promise we're getting there. We've just seen so many delays, and not really any fault of our own for the most part. So let us know your thoughts. Let us know your comments. Really anxious to hear them. I hope you guys are as excited as I am. And yeah, when I know more, you guys will know more. So I'll keep you guys posted. And until then, I will see you guys next time.